Dr. Ploeg, it was an amazing discussion we had this morning on the clinical trials in the field of kidney transplantation. And you, of course, presented the COPE studies that were quite intense, I can imagine. There was a combination of at least 3 large clinical trials in machine perfusion. It's very amazing. How can one man, one team manage 3 different clinical trials at the same time? How did you do that?
Well, thanks very much. Of course, that's a very relevant question. It's not one man. It's a very good group of people who have known each other for the past 15 years, because the COPE Consortium, which means Consortium for Organ Preservation in Europe, started actually probably 10 years before we actually got the award from the European Commission. We know each other, we've worked with each other, we did previous studies, and I think that's why it works, because there's trust. Yeah. And because if people trust and they have their own thing in the study, they feel like committed, and that has worked. The reason why we did COPE is we thought, well, there's so many options now of preserving organs much better. Which combination is now best? And of course, since it's 4 years ago, we knew then that some of the things could be combined, and those were the 3 trials we tested. The liver study, warm versus cold, and 2 kidney studies, which were cold but with or without oxygen.
Okay, so you really built on the history of what you did in the past, on the trust you had, on the friendships perhaps that also arose from these collaborations. Does it also mean that it's difficult for other people to then start doing this kind of research, or do you really have to be in the field for a long time, or can you, or can you really expand this kind of research also across other centers, across other countries that have not the experience? Because what we see in your COPE trials is that it's Western European centered. Would that something possible also in Eastern European countries, Asian countries? We have many people from outside Europe also listening to this broadcast, so for them it would be interesting to have your vision on that.
No, I think we call each other Consortium for Organ Preservation in Europe, so it's not exclusive Western Europe, which by the way is not even true, because, well, you can't really talk about West and East anymore. We have in our trials, we have very important centers who are more Central Europe. For example, Semmelweis University in Hungary, a very important partner for one of the trials, because they do a specific number of kidney transplants in high numbers. The idea is actually to kind of give this on to the next generation and further expand. So we would really like to see other groups from other centers and other countries to get on board. Yeah. The structure was now the seniors should always bring a junior. So the trials were always done by a senior work package leader and a junior young surgeon, PhD candidate, whatever.
So that
and I think that's the idea. Yeah. So these people are the one who will continue.
Yeah, that's nice. And so, of course, the studies are not finished. We are still awaiting some results. But assume that the hypothesis is correct, that with machine perfusion and with oxygenation, you have a better preservation. Is that an opening towards organ resuscitation labs, the organ recovery hospitals, as we heard in the presentation by Gerald Barnacher? Is that really something you would dive into? Is that something that is possible and feasible in the future?
I think it's happening. Look, for example, the experience we have in Oxford with the liver. We did liver transplantation after 25 hours, and we have successfully preserved those livers for hours. Peter, friend, and Konstantin Kosius, who developed the liver machine, have done a lot of experience before then, and we have now the liver device in our lab, which we can use for discarded livers, and we try to find out how we can repair them. We now have a very nice experimental setup also for kidney perfusion, using both devices from Organ Assist and from Organox to see whether we can preserve kidneys for 24 hours.
Okay. And does that mean that also the practice of transplantation would change? Because if you're talking about 25 hours liver, 24 hours kidney, it sounds like possible to move towards daytime surgeries instead of emergency surgeries.
Well, one thing, of course, is daytime surgery, which is, of course, nice for the surgeon and for the staff. However, I think it's more relevant to say, why do we want longer normothermic perfusion? We can still transplant within so many hours.
Okay.
But I think the reason to do that is because we think that if we do ex vivo repair, we need a certain number of hours.
Okay.
We know that after 1 hour, the kidney is resuscitated and it will function. And Mike Nicholson from Cambridge now has demonstrated that's very feasible. But that's not enough for repair. So if we want to repair the organ, we need at least 5, 6, 7 hours of warm. We've now first shown that some of the so-called regenerative factors, like hepatocyte growth factor, will show themselves after 6 hours.
Okay, and so if you're talking about regenerative factors, regenerative medicine, of course we have also heard from, for instance, the one study where they have all these studies on cells and regeneration of cells. Is there some link possible between regenerative medicine and machine perfusion? Do you see there some future in that
I think
collaboration?
that's an excellent question. So what we're actually trying to do at this moment, there's our consortium which is focusing on optimal preservation and perfusion. And there's another consortium which also was in the EU 7th framework, Stellar. And they have very sophisticated knowledge on stem cells.
Okay.
And what we are actually now making together is a new consortium which is called COLLAR, which is COPE plus Stellar is COLLAR, which will be the combination of normothermic preservation with stem cells. And the idea, of course, that if we infuse the stem cells on a device outside the body, it's very safe. We can look what it's doing.
Okay.
Is it improving the organ? And is it helping after transplantation to repair?
So you have already a very long-standing career in transplantation. You have been involved in the field for many, many years. You developed together with Belzer the University of Wisconsin solution, as you explained in the movie. You are now working on machine perfusion. You are diving into regenerative medicine. If you look back to your, let's say, history, what would be perhaps the main legacy that you think you will have contributed to the field of transplantation? It's a difficult question, but a man like you could perhaps.
Well, I don't like to talk about legacies. I'm still alive.
Yeah, why not?
So first to correct one thing, the UW solution, University of Wisconsin solution, was developed by Dr. Belzer and Jim Southard.
Okay.
And Ralph Sundberg, Jan Warburg, Neville James and I were the first fellows to work with it. So we were just happy and lucky to be there and
We were
work
really
with it.
pioneering with the pioneers.
No, and it was fun because we had to do the first experiments, and then when I took that back to Europe, we did the first trial.
Okay.
And I think we can proud of it that within Eurotransplant we actually convinced everybody that UW was a very good preservation, and until today it's standard.
Today,
But I think what I would like to say, what I love most is to be in this creative process, which for me turns out to be transplantation and organ quality and preservation, and be there with a lot of very nice colleagues and young people, have a good idea. Sometimes it's ridiculous, but sometimes it's good, and we can actually transform it into a good study which then works, and I think that is the fun. So if you talk about legacy, making maybe translation from a good question into a model and into a trial, I mean that's what I'm going for.
That's just fantastic. Thank you so much for this interview.
Okay, thank you very much for the opportunity.
Thank you.
Bye-bye.